What's up, guys? This is Will Youngle, your math teacher for Algebra 1 or Advanced Algebra 1. Today we're going to go over something called one-step equations. And the nice thing about it is it takes one step to solve the problem. You may have seen it before. Regardless, we're going to take a look at some things. So starting off, again, we're talking about one-step equations. So we need to talk about some vocab that you may not be familiar with. The first vocab word we need to learn is a variable. So you might hear me use the word variable. And what I mean by that, it is simply a letter that I'm addressing. It's used to represent an unknown quantity or amount in an equation. So if you see this equation down here, it says, let me get rid of this real quick. It says x plus 5 equals 9. So the variable in this equation would be x. Next, there is something called a constant. A constant is a fixed value, a number, that does not change. So, for example, the 5 is considered a constant because it is not currently changing. So, jumping into that, let's talk about one-step equations. So, starting off with our first problem. It says x plus 5 is equal to 9. Now, up in our heads, I know we can think about it and say, what number plus 5 would give me 9? And most of y'all are probably like, yeah, I got it. It's 4. It's not that difficult. But that's good, and I'm glad you know that. But when we start getting into math a little, that takes more than one step, as we mentioned before. When we start taking problems that take 4 or 5 steps, you can't just guess what x is that easily. It's going to take a lot more talent. So let's start learning how to solve these correctly, and from there we will learn some shortcuts. So what number plus 5 is 9? Well, we need to get rid of plus 5. What is the opposite? Think of the opposite of positive 5. Clearly, that would be negative 5. So if I write, let me change colors for y'all. If I write minus 5, if I do it on one side of the equal sign, I have to do it to the other side. When this happens, plus 5 and minus 5 are canceling out, leaving you with just x on one side of the equal sign. And 9 minus 5 is in fact 4, the number that we guessed earlier. And that's the end of that problem. It took one step to solve. We subtracted 5 from both sides. Okay, next example to talk about is number 2. X minus 3 equals 10. Well, we have x again, our variable, and minus 3 equals 10. I want to get rid of minus 3. How do you get rid of a minus 3? Well, obviously we need to do the opposite of minus 3, which would be plus 3. But if I do it to one side, always remember we must do it to the other. This leaves us with x equals 10 plus 3, which is 13. All right. Moving on to our next problem. I gave this one to us because it's almost exactly the same as number 2, but it's written differently, and this kind of freaks people out sometimes. So, for example, I have negative 2 plus y, our variable, equals 7. Well, the y is fine. I want to keep my y on this side, but I need to get rid of a minus 2 or a negative 2. What's the opposite of that? Clearly, that would be positive 2. And if I do it to one side, I must do it to the other side of the equal sign. Cancels out. And we end up with y is equal to 7 plus 2 is in fact 9. And honestly, guys, if you need to, take your answer and plug it back in and just see if it works. For example, what is negative 2 plus 9? Well, negative 2 plus 9 is 7, so you know for a fact that you got the right answer. Okay, next one, number 4, x over 5. So I know this looks like a fraction. It is a fraction, but what does this bar actually represent? It represents division. So x divided by 5 equals 20. Well, how do you get rid of something divided by 5? Obviously, we want to do the opposite. So opposite of division is multiplication. So I'm going to multiply both sides by 5. Again, what you do to one side, you must do to the other. We end up with x is equal to, 5 and divided by 5 do cancel out. 20 times 5 is in fact 100. End of problem. Okay, going down here to number 5. I put a bunch of 5s just to keep y'all entertained. So 5z equals 55. First step, this is 5z. What that means, you don't see a plus or a minus sign between those two. That's all one term. We'll get into that vocab later. 5 times z is what is being implied here, so multiplication. What is the opposite of multiplication? That would be division. So I need to divide both sides by this positive 5. So 5 over 5 does cancel out. It's really 1. 1z is equal to 55 divided by 5, which is in fact 11. Okay, going to our last example. I'm going to try to show both of these at the same time here. So we have negative 3p. A lot of y'all do not like negatives, which is why I put it in here. So negative 3p is equal to negative 30. Again, this is multiplication. Negative 3 times p. There's no symbol between the 3 and the p. So we know we can get rid of multiplication with division. And if I do it to one side, I'm going to have to do it to the other. Final step. How do you get rid of negative 3? Well, I need to divide it by itself. Because remember, anything divided by itself is 1. So negative 3 divided by negative 3. If I do it to one side, I must do it to the other. Negative 3 divided by negative 3 is 1. In this case, 1p. There's no need to write the number 1 in front of it because it's already implied. And tricky part, does anybody remember what a negative divided by a negative is? That would be a positive. And in case you forgot, I wrote a little cheat sheet for you here. Positive times positive, all these little shortcuts for multiplication actually also work for division. So in this case, a negative divided by a negative is positive. So positive 30 divided by 3 is 10. Now it's definitely a little tricky. We'll get more comfortable with these as we continue on. Hope y'all have a great day, and I'll catch you later.